right, you're live.
All right, in the drawing exercise for this lesson, we went through a sequence of nested circles based upon a expansion ratio of the square root of 2. So we began with this diagram right here, and I'm assuming you already know how to set this up, so we're not going to get into that. But we began with this diagram right here, where we have cross axes an X and a Y axis, and 2 at 45-degree diagonals to the principal ones. And that divides our circle into 8 equal parts, which would be the basis for the construction of an octagon. But we're not going to go into that with this particular lesson. What we're interested in doing is enclosing that circle in a square. Now, we went through this procedure in the drawing exercise, so you would know how to do this now with your compass and straight edge. And what we do is take a succession of squares with inscribed circles, such as you see right here, and then we circumscribe another circle about each square, and each of those circles yields the next generation in the composition. So that circle becomes enclosed in a square, and then we circumscribe that square in another circle. And what we do here is we have a constant proportion of expansion based upon the square root of 2. Each of these circles is their diameters, and as well as their radii, is growing by the square root of 2. And so again, this gives us this particular sequence, which I will be showing you some future examples of how this particular sequence of rhythmical square root 2 expansion serves as the basis for developing quite a number of the ancient sacred structures. And we find this particular expansion ratio in nature, which is quite interesting. We'll enclose this in one more square like this. And we talked about the process of impacts into planetary surfaces.
Sorry.
So,
Just a moment. Let's go outside.
we talked about impact processes, where a bolide, an object from space, crashes into a planetary surface, liquefies the surface, and creates a series of radially emanating surface waves moving out in that root 2 ratio. This is a painting by William K. Hartman showing the early stages of the Great Cretaceous Tertiary impact crater flanking the coast of the Yucatan, the Chicxulub crater actually it's called. And these two rings are related to each other in that root 2, by that root 2 ratio. And that ratio being found in these concentric rings on other planets was early on one of the criteria used to actually determine whether it was an impact structure or a volcanic structure. Of course, now we know that most of them are impact structures, and it requires, a certain size of object in order to create the multi-ring, because you don't get the multi-ringed effect with the smaller objects. And here's Mare Orientale on the moon, where the root 2 spacing ratio is pretty clearly indicated, and I'm going to superimpose the pattern that we just developed on it, and you can see that it conforms to the to this spacing ratio. Now we're going to go into the second part of the drawing exercise that we did. We begin with the same configuration, the square with an inscribed circle, divided by horizontal, vertical, and diagonal axes. And we're going to begin our progression as we did in the preceding exercise, but this is, we're going to deviate off into another direction with this. So we'll enclose it in a circle. We'll circumscribe a circle, just exactly as we did in the preceding exercise. And then we're going to project the sides of the square on out, as I show here. And the reason we're going to do that is because we want to develop an expansion ratio based upon the succession of root geometries. So here we have the root 2. We have if we establish this radius right here as 1, then this radius right here becomes the square root of 2. And we're going to enclose that in a square. Now, what has happened here is we have created a new point, or a series of points actually, in our diagram here, and we'll define those just like this. So now you can see what we've got here is that this is the root 2 rectangle. We've created a whole series of root 2 rectangles within this one pattern. You can see, you can count them. Look, here would be 1, here's 2, 3, 4. So there's at least 8 right here that you can see, that you can count around here, 8 root 2 rectangles. And we've inserted some diagonals here into those root 2 rectangles. Let's just take this one right here, like this. We'll say this is a root 2 rectangle. And we generated that, again, because this length right here is equal to the diagonal of this first level square right here. Then when we take the diagonal of the root 2 rectangle, as you should now be well aware from the exercises we've done, this diagonal is going to be the square root of 3. All right? So within this one figure, we think of now the square as being a root 1 rectangle. Its diagonal gives you the root 2. That root 2 diagonal yields the next generation in the diagram, which is the root 2 rectangle, and its diagonal gives you the square root of 3. So we are now going to we're not going to circumscribe the circle this time, because this circle is actually going to clip the corners of that previous square. Let's take it off again. Now look, what we're doing is we're using this root 3 as the radius right here. So we set our compass to this point, and we use that to generate the circle. Now from that we get 4 points around, like this, at noon, 3 o'clock, 6 o'clock, and 9 o'clock. We get those 4 points, and we use those points along with these radii, just as you should recall from the video of the drawing exercise of this diagram. So we enclose that in a square, like so. And now, once we've enclosed that square, look what we've got. We had the root 1 rectangle, the root 2 rectangle, and we used its diagonal, which gave us the root 3, which is equal to this length right here, the radius of our most recent circle that we've drawn. And so now what we have here is a root 3 rectangle. Begin to see this beautiful progression from root 1 to root 2 to root 3, which we've already done, but now we're doing it with biaxial symmetry. We're showing the whole pattern here. So let's go to the next level. And you see right here, it's this intersection of these projected lines with the enclosing squares that gives us the succession of points that we're interested in. So now we'll go to the next one. We're using this line right here as our radius. That gives us another circle. So what we're seeing here is here's our root 1, here's our root 2, and here's our root 3 with its diagonal. And so we're going to use, again, our 4 points at noon, 3 o'clock, 6 o'clock, and 9 o'clock to get these corners, to develop the corners of the next square in the sequence. And then that next square gives us this point right here, this point over here, down here, and so on. And there we go, right here. Okay, I think you see where we're going with this thing. We can now use this as a radius, and it gives us this circle. Each circle gives us the points we need to establish our next square in the succession. And there we go. So you see what we've got here. notice this is 1, or the square root of 1, the square root of 2, the square root of 3, the square root of 4, the square root of 5, and finally the square root of 6. And you can take your calculator and, of course, instantly get these. If I hold up my calculator here in front of the camera, let's get this like this. All you have to do, how simple this is put in the number. We want to know what's the value of the square root of 6. Right there, like that. We just hit this button right here, square root button, and there it is, 2.449. For practical purposes, you could think of it as 2.45. Close enough for most practical work. And you see how easy it is to get any of these. We want to do the square root of 5. Just hit the square root button right there, and there's the value. So if you've got, let's say you've got a root 5 rectangle. You're laying out some design based on a root 5 rectangle. It means that it's the ratio of its long side to its short side is the square root of 5 to 1. So whatever the short side is, you simply multiply that by the square root of 5, and that gives you the length. Let's suppose we have a 1 foot square. We've got 1 square foot and 12 inches. So you want to know how many inches. Let's say that's going to be the short side of a root 5 rectangle. So you want to know how many inches would the long side be. Well, then all you do is we'll do it again. We've got 5. We square root it. There's that value. And we would go times 12 equals, and theirs would be the length in inches, 26.83 inches. It's that simple. Okay, now what's interesting about this pattern right here is this serves as a master pattern or master diagram from which you can develop the whole symphony of ratios that were used throughout the various expressions and examples of sacred geometry through history. It also served as the basis for the development of sacred metrology. So I'm going to talk about that for a second. Metrology is the study of the history of measurement, the units of measurement, the systems of measurement. And as it turns out, this was very important within the sacred canons of olden times in many respects. It certainly played a very significant role in Christian symbology, not only in Christian symbology, but throughout. For this exercise, we'll look at some of the Christian symbolism in a second here. So this is the basic diagram that you see right here. This would be the basic master pattern. I'm inserting the various diagonals so that you can see these relationships and how the succession of relationships develops. And you should recall from a previous lesson that when you get the double square, which you can see 1, 2 right here, within that, its diagonal is going to be the root 5, and it's the double square with the root 5 diagonal that we use to get the golden section. So we're getting close to really delving in depth into the meaning and properties and symbolism of that golden section, and I really look forward to that part because it's very, very interesting. But you see, you have concealed within this diagram, you have the entryway into all of the golden section mathematics with this double square that we've generated. But you have all the rest of the stuff too. You have the ad quadratum geometry, you have the ad triangulum geometry, and now we have the golden section geometry, and they're all synthesized and unified in this one particular diagram. And now with this one I've inserted the additional diagonal so you can see how the symmetries of this pattern develop. So let's talk about sacred metrology, the systems of measurement. Protagoras, from 481 to 411 BC, said that man is the measure of all things. And this is a very interesting and important concept, because in this idea we have the principle of scale invariance, the idea that the proportions of the human being are the proportions of all creation, in effect. And we're going to see many examples of that as we explore deeper into this. One thing you might consider doing, just for a little aside for a moment, let's see if I can do this. Take a look at your fist. Let's see if I can get this up here, just like this. Okay. There's a spiral generated right here, and we'll look at this in more detail in the next lesson on the golden section. But there's a spiral that you can actually see when you make your fist like this, that wraps around like this. That spiral is a golden spiral. It's based upon a constant expansion factor of the golden, based on the golden section. And we'll be drawing that in the future, and we're also going to be looking at that, because in the human proportions we find embodied safely the dimensions of the cosmos, and that's where sacred geometry really starts to get interesting. But what I want you to do here is to see now how this master diagram that we've drawn served as a unifying pattern to develop, or to generate, from which to generate the sacred measurements used throughout history. So we'll look at some biblical quotes, because people need to know that not only in many traditions, such as the Vedic traditions and the Sumerian and Egyptian traditions, but much of that was preserved in Christianity. And since Christianity is the dominant religion of Western civilization, of the United States right now, I like to draw in information culled from Christianity and Christian symbolism to show that there is this esoteric information encoded there as well. So Isaiah the prophet says, "Who hath measured the waters in the hollow of his hand, and meted out heaven with the span, and comprehended the dust of the earth in a measure, and weighed the mountains in scales, and the hills in a balance." Now, let's talk about a couple of these things. Heaven with a span. Span could be one of two things. It's your outstretched arms. It could also be, let's do it, if you stretch out your hand like this, the distance from thumb to the small finger across here was also called a span. So you could think of the great architect of the universe reaching out his hand and impressing it upon the undifferentiated chaotic energy material matrix of creation, and bringing it into order by imposing this method of measurement upon it. So comprehended the dust of the earth in a measure, weighed the mountains in scales, hills in a balance. Here it's trying to convey this idea that nature as we see it is not a random process. In Ezekiel, the Old Testament prophet, he says, "In the visions of God, he brought me into the land of Israel, and set me upon a very high mountain, by which was the frame of a city on the south. And he brought me thither, and behold, there was a man whose appearance was like the appearance of brass, with a line of flax in his hand and a measuring reed. And he stood in the gate. And the man said unto me, Son of man, behold with thine eyes, and hear with thine ears, and set thine heart upon all that I shall show thee." So here we have the introduction to the prophetic vision. And what forms the basis for this introduction into the prophetic vision is that Ezekiel sees this man. And the man has a line of flax in his hand and a measuring reed. So with these two implements, these were the two basic implements by which one was able to establish the ground plan of the sacred structure. In this case, what he's doing is he's instructing the prophet Ezekiel to behold with his eyes, to hear with his ears, and to set his heart upon all that he will show thee, to really take it in and integrate it and make it a part of his inner being of his inner consciousness, because this was the key to understanding the frame of the holy city. And the holy city is the ultimate symbol for the repository of the principles of sacred geometry. The holy city, in effect, is a symbol of the universe and the cosmic pattern by which order and ultimately life and sentience is brought out of that initial chaotic matrix. Zechariah says, I lifted up my eyes again, I looked, and behold, a man with a measuring line in his hand. Then said I, Whither goest thou? And he said unto me, To measure Jerusalem, to see what is the breadth thereof, and what is the length thereof. Now this doesn't mean that he's literally going to go and measure the city of Jerusalem in its real world context. It means that essentially we're talking about Jerusalem as the holy city, as the symbol of the world, you see. And so again, once again, the initiation of the prophetic experience begins with the prophet encountering this man with a measuring line in his hand. If he's got a measuring line in his hand, you know immediately he's an architect. And so he has the measuring line, and when Zechariah inquires as to what he's up to, where he's going, he says he's going to measure Jerusalem to see what is the breadth and what is the length thereof. In other words, he's going to look for that proportion between length and width. Exactly the kind of thing that we've just been studying. And in the New Testament, in the book of Revelation, we find this. There was given me a reed like unto a rod, and the angel stood, saying, Rise and measure the temple of God, and the altar, and them that worship therein. Again, the prophetic experience is being inaugurated by an act of measurement. And you see here, he's the angel. In this case, in the two preceding cases, this figure of the architect is described as a man. In this one is described as an angel. And you'll see that in these sacred encounters, there's kind of a morphing that a reciprocal morphing that can take place back and forth. The man can become an angel, the angel can morph back into a man. And the angel says, Rise, measure the temple of God, the altar, and them that worship therein. Three things: the temple, the altar, and them that worship therein. So when John, who undertakes this process of measurement, measures these three things, what do you think he finds? What he finds is that there's a common proportion, a common linking geometry between the temple itself, the altar within the temple, and the geometry of them that worship therein. That's the key insight here, is that there's a common geometry linking these three things. What is implied or here, but not necessarily stated overtly, is that further the temple itself is now linked to the greater world as a whole through this same constant of proportionality. And so there's a dynamic that goes on between the altar and between the temple as a whole, right? There's an expansion factor that takes place. And linked within that, between the altar and the temple, is the worshiper, setting up a unifying geometry that links the geometry of the altar and the temple, which are scale invariant representations of an invisible pattern. Because the idea here is that the temple as built is basically a material expression of a pattern of energy that pre-existed, that was there at that spot, at that site, at that sacred site, before the actual construction of the temple. And it's the purpose of the architect now to actually frame that pattern of energy in material so that it now becomes visible, something that a person can see, something that the worshiper can enter into and dynamically interact with. In the Mayamata, which was a treatise, a Hindu treatise on the dwellings of gods in man, set down several thousand years ago, part of the Vedic tradition, it says, if the measurement of the temple is in every way perfect, there will be perfection in the universe as well. Now this brings us to an interesting concept which we're going to be talking about and returning to quite frequently from here on in dealing with this material. And this is the principle of reciprocity. that there is a relationship between the small and the large. In this case, the temple and the universe. And the idea here is that energy and information can be uploaded and downloaded. It travels in both directions. And that something that happens on the level from the universal scale, the temple is a micro scale level, right? And it's very much in some of the material that I presented about DNA replication. You see, what we have in DNA replication is a microscale phenomena that creates the form of the greater entity. You see, the form of the greater entity is dependent upon the pattern that's within the DNA molecule. So what we have here is we think of the temple as a DNA molecule. And from that temple, a seed, the universe grows. And if the proportions of the temple are appropriate and correct, then the universe or the cosmos that grows out of that temple will then contain that perfection of proportions as well. So we generally think of the influence coming from the greater world to the lesser, from the universe flowing down into the temple. But again, here the idea is reciprocity. It flows back, you see, and then it sets up a series of amplifying feedbacks. That's the idea, so that the energy then becomes concentrated into the material form of the temple itself. So not only is the position of the temple important with respect to the surrounding cosmos, but the measure, the modulus of the temple is critical as well. And so here now we're going to refer back to our discussion of sacred metrology. We're going to look at some of the units of measurement that were used in ancient times. We're going to begin with the one called the remen, which was an Egyptian unit of linear measure, first analyzed by F.H. Griffith in 1892 and by William Flinders Petrie and A.E. Berryman. Considered to be equal to 20 digits or 4.58 inches, A.E. Berryman, in his work Historical Metrology, refined the length of the remen to 1.2165 feet. Okay, so now the digit was kind of a unit of measurement, perhaps from Egypt, that appears to have been used universally in the ancient Mediterranean world, and 20 of those digits yielded 14.58 inches. So this was the remen. The other unit of measurement that was used in ancient Egypt was the royal cubit, discovered by Isaac Newton in his analysis of the dimensions of the King's Chamber of the Great Pyramid. And that was based upon the survey of Greaves that was performed in 1637. It was also mentioned in the writings of Herodotus in his description of the city of Babylon, and with slight variations, the accepted length of the royal cubit is taken as 1.72 feet or 20.6265 inches. Now let's stop for a moment here, and we're going to look at the relationship between these two. If you get out your calculator and work with me on this, you see that the remen was 14.58 inches or 1.2165. The royal cubit was 1.72. Now what I want you to do is to look at this relationship between these two units of measurement. So put in 1.72 in your calculator, 1.72, the length in feet of the remen, and divide that by 1.2165, and you'll get something about like this. Now, if you square that number, look what I've got here, 1.9999, in other words, 2. When you square, you took the ratio of the royal cubit to the remen. When you squared it, you got basically 2. So in other words, this ratio between the royal cubit and the remen was the same as the diagonal of a square to its side. So if you had, and this is presumably what the Egyptians were doing here, if they had one square remen on a side, 1.72 feet or 20.6265 inches, and they took its diagonal, that diagonal was the royal cubit. So the royal cubit and the remen had this relationship to each other. Well, See, the interesting thing about this, which I'm hoping now you're beginning to understand about these dynamic root ratios, is that if you go from length, a single dimension, up to area, 2 dimensions, you'll see that, first of all, in the single dimension, in terms of length, these units of measurement are incommensurable. The root 2 is an incommensurable number. So the diagonal of a square to its side is incommensurable because of the fact that you can express one or the other as a whole number, but only one of them. If you express the side of the square as 1, its diagonal is the square root of 2, and we could at some point, perhaps, if anybody is interested in this, I could show them why we can prove actually that the square root of 2 is an irrational number, meaning that the square root of 2 never repeats, never terminates, just like a pi, for example. It never repeats, never terminates. It's an irrational number. So is the square root of 3. Obviously, the square root of 4 is 2, so it's perfectly rational. But the thing I want you to appreciate here is that if you take one square Riemann on a side, one Riemann on a side, its area is 1 square Riemann. Now, you take the diagonal of that, while the diagonal, the length of the diagonal to the length of the side of that square is incommensurable. If you draw a square Riemann, a square royal cubit, its area is going to be exactly 2 square Riemanns. So in terms of length, incommensurable. In terms of area, perfectly commensurable. So that both areas can now be expressed as whole numbers. So we've got the Riemann, then we've got the royal cubit. Now, the next thing we're going to do is we're going to look at another unit of measurement that was used in Palestine probably between the first millennium BC, roughly for 500 to 1,000 years. As it says here, knowledge of the Palestinian cubit survives in the writings of Epiphanius, a bishop of Constantia in Cyprus, who wrote a treatise on weights and measures in AD 392. The Palestinian cubit conforms to the cubit of the altar, as mentioned in Ezekiel 43:13. That is, the cubit and a hand's breadth, which is this right here. The cubit, if you can't see the hole, the cubit is elbow to fingertip, and then you simply put the line of your knuckles at the tip of your middle finger, and that's the cubit and the hand's breadth. And this was the basis of the Palestinian cubit, which was generally taken as 2.107 feet. Well, let's recall that the Riemann was 1.2165. So again, take your calculator now, put 2.107, the length in feet of the Palestinian cubit, which would have been used up to 1,000 years later than the Egyptian Riemann and royal cubit. But look at the relationship between the Palestinian cubit and the Riemann. So divide this, 2.107, divide it by 1.2165, and you will see that what you have is 1.732, which hopefully at this point is a familiar number to you. Just square that number, hit your squared key, and you'll see what we've got, 2.99999, or basically 3. So in other words, when we squared this ratio, we got the square, we got 3. So this ratio is the square root of 3. Okay, so now we've got this Palestinian cubit is linked into a geometric sequence along with the Riemann and the royal cubit, which perhaps suggests an ultimate origin for the Palestinian cubit, perhaps. Well, let's go on. In Roman times, there was used the Roman pace. It was 1/1000th of the Roman mile. It was equal to 8 stades of 607.5 feet. Hence, it was equal to 4.86 feet. This would make the half pace or stride equal to 2.43 feet. Okay, so now we're looking at Roman times, which was about 2,000 years ago. We're looking at the unit of measurement that was used in Rome, roughly 2,000 years after the royal cubit was being, and the Riemann were being used in Egypt, in Rome. So we've got a geographic distance, and we've also got a temporal distance of a couple of thousand years. But notice here, 2.43 feet. Put in 2.43 in your calculator and divide by 1.2165, to get the ratio between the Roman pace and the Riemann, and you'll see right here it's 1.99, or basically 2. What happened here? What's going on? Actually, we're interested in this 4.86, because what you're seeing here now is that this is the double square. I've got illustrations of this coming up so that you can see soon enough. Okay, then we have the megalithic yard, discovered by the Scottish engineer Alexander Thom, who in the 1960s and 70s surveyed and analyzed over 500 megalithic remains and stone circles throughout the British Isles. The megalithic yard was determined by Thom to be equal to 2.72 feet, plus or minus 0.003 feet. So now we have this 2.72, and we're going to do the same thing. We're going to take 2.72, put it into our calculator. We're going to divide it by 1.2165 to look at the relationship between this megalithic yard that was being used in ancient Great Britain, and it was roughly contemporaneous with the Old Kingdom of Egypt. So while the Riemann and the royal cubit were being used in Egypt to build temples, and presumably the pyramid, because after all, remember, the royal cubit was discovered by Isaac Newton in his analysis of the dimensions of the King's Chamber of the Great Pyramid, right? So now we have the megalithic yard, roughly contemporaneous with the Old Kingdom of Egypt, being used to construct these stone circles and so on in the British Isles. And it was through an exhaustive statistical analysis, Alexander Thom came up with the ratio of 2.72 feet. So when we divide that by the length of the Riemann, we're going to get this number right here. And when we square that number, you see we get 4.999, or 5. So again, what's happening here? Now the megalithic yard to the Riemann is as the square root of 5 is to 1. So let's think about what we've demonstrated here. If you have a double square, its diagonal of that double square is the square root of 5. And it's this relationship we've discovered, or we've been informed anyway, is the basis for generating the golden section, right? Okay, so now if the side of that double square is a Riemann, and each of the squares is now a square Riemann, we put two of those together, and we have a rectangle that is one square Riemann on its short side, or one Riemann on its short side, two Riemanns on its long side. Its diagonal is going to be the megalithic yard. Coincidence? We don't know at this point. If it is a coincidence, it's a very interesting one, isn't it? Finally, we look at the modern yard, which is 3.0 feet or 36 inches, and we discover, if we do this same mathematical process, that the Riemann times the square root of 6 is 2.98 feet or 35.76 inches, which is almost a yard. So our modern yard almost fits in to this, into this pattern. In fact, I would be willing to bet that if I were to lay out a rectangle that was one Riemann on its short side, and it was one megalithic yard on its long side, we take its diagonal based on the root 6, most people wouldn't be able to tell that that was not a modern. They would not be able to tell that that was just a little bit less than 1/4 of an inch deviation. Okay, so let's take a look here so you can really visualize what's going on. One square royal cubit was equal to 2 square Riemanns in area. So this exact area of these two added together equals the square royal cubit. If we take 1 square Palestinian cubit, it was equal to in area to exactly 3 square Riemanns. So if we were able to, cut this up and fit it into this 1 square Palestinian cubit, exactly 3 of these Egyptian Riemanns would fit within the Palestinian cubit. We look at the 1 square Roman pace, and it's equal to exactly 4 square Egyptian Riemanns in area. Again, perfectly commensurable. this link now between units of measurement being used in Roman times. In fact, the whole Roman mile was based upon 1,000 of these paces, and the city of Rome was laid out on this this grid that was based upon the 0 point of the north, south, east, west axes being the center of Rome, and everything was measured out from that according to miles is where we get our miles. Remember, the word mile comes from the word mil, which means 1,000 in Latin. And so a mile was 1,000 paces. So this is where the Roman mile came from. It was 1,000 of these Roman paces. But if we took 1 square Roman pace, we discovered that it's got this perfectly commensurable relationship with the Egyptian remen used 2,000 years earlier in Egypt. Then we go to the megalithic yard, and we see the same process happening here, the same relationship. 1 square megalithic yard is exactly equal in area to 5 square Egyptian remens. So now think about this. 4,000 years ago, in Egypt, you've got builders, you've got architects using Egyptian remens and royal cubits to lay out sacred structures. Simultaneously, thousands of miles away in Great Britain, you've got architects laying out stone circles and megalithic structures using the megalithic yard, which is directly related by geometry to the Egyptian system of measurement. Finally, one virtual square, I call it a virtual modern yard because it's not quite a modern yard. It's a little bit shy of a modern yard. We look right there, and we see that 1 square virtual modern yard would be equal to 6 square Egyptian remens in area. Okay, so now when we go back to our diagram,
Try clicking on the screen and then checking it.
there we go. Okay, so there, this is what we're looking for, the master diagram of sacred metrology. So now you can see a practical expression of some of these quotes that I presented to you, and there was actually quite a few more I could have culled together for this lesson, but we don't want it to get overly long here because I think you're starting to get the idea. So when you look at this master diagram of sacred metrology, what do you see here? Here would be the remen, then you would have the royal cubit, then you would have the Palestinian cubit, then you would have the Roman pace, the megalithic yard, and the virtual modern yard, all linked by this dynamic symmetry. Again, is this a coincidence that these units of measurement are linked like this? Who can tell? But I find this to be a very, very interesting system. And my conjecture would be that there's something more than coincidence going on here. That perhaps we had a universal system of measurement that was being dispersed to various builders and architects in these ancient cultures that were then used to lay out their temples and their sacred structures, and would ensure that by using these units of measurement, they were linked into a universal system. So we will be exploring this particular pattern and its implications in much greater depth as we go forward from here. I hope you enjoyed this lesson, and I will be looking forward to our next get-together. We'll leave that. The last one there will be where we pick up for the next one, because what I'm going to do is create a PDF.
Okay. Do you hit Control-Shift-S?